Hello everyone. Today I would like to talk about vector quantity and its linear operation. At the beginning of today's lesson, I will introduce the definition of vector quantity, and then we will discuss the linear operation of vector quantity. At last, we will learn what is the Cartesian coordinate system and try to use it to solve the vector quantity question. So, now let's talk about the vector quantity. Firstly, what is vector? As the picture of vector AB shows below, a quantity possessing both magnitude and direction. Point A is called tail of vector AB, and point B is called the head of vector AB. And how about the opposite vector? Vector A is given, and the opposite vector of vector A is negative vector A. It has the same magnitude as vector A, but that is pointed in the opposite direction. Someone may ask, what is the magnitude of vector A? It is called norm of vector A. There's another special vector which is zero vector. It has no length and not pointing in any particular direction. After the definition of vector quantity, here's another question. How to do the linear operation of vector quantity? First, let's talk about the addition of vectors. Here is a question shown below, giving you vector A and vector B. Try to find vector A plus vector B. There is an important point we should do first is that translate vector B until its tail coincides with the head of vector A. It can help us to solve this question. Here we see the green line vector C. The directed line vector C segment from the tail of vector A to the head of vector B is the solution of vector A plus vector B. So vector A plus vector B equal to vector C. Attention! The principle here we use is vector triangle. After the addition of vector, then let's talk about the subtraction of vector. Vector A and negative vector B are shown. Negative vector B is the opposite of vector B. Vector A minus vector B equal to vector A plus negative vector B. Now we change it to the addition of vector. The answer is vector C. The principle we use here is also vector triangle. At last, let's talk about the Cartesian coordinate system. It is a given coordinate system as an ordered three-tuple of real numbers x, y, z with respect to the origin 0, 0, 0. As the picture shows below, Cartesian coordinate system is right-handed coordinate system. If you take your right hand and point it along the positive x-axis with your palm facing the positive y-axis and extended your thumb indicates the positive direction of z-axis. So, how to do the linear operation of vector quantity by Cartesian coordinate system? Here, given a cuboid in Cartesian coordinate system, vector BA equal to vector A, vector BC equal to vector B, vector B1 equal to vector C. So, how can we solve the vector OB1, which is vector R? Now here is the solution. as vector BA equal to vector A, vector BC equal to vector B. Also, vector BC is parallel to vector AO. So, vector BC equal to vector AO equal to vector B. Also, vector BA plus vector AO equal to vector A plus vector B equal to vector OB. Vector OB plus vector BB1 equal to vector A plus vector B plus vector C equal to vector B10. And vector B10 equal to negative vector OB1, which is equal to negative vector R. So, vector R equal to negative vector A plus vector B plus vector C, which is equal to vector A minus vector B minus vector C. That's all for today's lesson. Thank you for watching.